In this video, we're going to write equations of lines when given 2 points or when given a point and a slope. So first we're going to go over the forms of the equation. So slope-intercept form is y equals mx plus b, and point-slope form is y minus y1 equals m times x minus x1. Both of these forms are labeled for the information that they give you. Slope-intercept form gives you the slope, which is m, and b, which is the y-intercept, or where that line crosses the y-axis. Now, in the form of the equation, we have y equals 3x plus 8. So 3 would be your slope, and 8 is the y-intercept. That actually represents the point 0, 8. So if we were to plot that point, that would be our y-intercept. Point-slope form is named that because you have a point and the slope in it. So the slope is m, and x1, y1 is your point on that line. So x1, y1 is any point on that line, m is the steepness. So here we have that equation. Y minus 5 equals negative 2 times x minus 3. Negative 2 is your slope, that's your m value. And then we have y minus y1, that's the y value of that point, equals negative 2 times x minus 3, which is the x1, or the x value of the point on the line. So based on the information that we're given in a problem, we can choose the form of the equation that would work best for that problem. Here's an example of point-slope form where we have y plus 3 equals 2/5 x minus 4. That 2/5 is your slope, that's your m value, but notice we have a plus 3. In our formula, it's y minus y1. Well, y minus a negative 3 would give us that y plus 3, because minus a negative turns into that plus. So as we look at getting the point out of that equation, that would be y minus a negative 3 would give us a negative 3 for the y value of that point. And then we have x minus 4, so it's x minus x1, so our x value is just 4. So the point on that line would be 4, negative 3. M would be 2/5. All right, we want to write the equation in slope-intercept form with a slope of 3 and a y-intercept of negative 2. So first we want to look at the information that we're given in the problem. We're given a slope of 3 and a y-intercept of negative 2. Well, we know our slope-intercept form has both of those in it, so all we have to do is make the slope our m value and the y-intercept our b. So y equals 3 n for m, x plus b as now negative 2. So we're just substituting those in. And now just simplifying, instead of plus negative 2, we would write minus 2. To graph that line, we would plot the point at the y-intercept, negative 2, which is the point 0, negative 2. So on the graph right here is 0, negative 2. From that point, we would use the slope to count rise over run. Since our slope is positive 3, that is rising positive 3, running positive 1. And so up 3 over 1, up 3 over 1. Another way we can get a positive 3 is also to go down 3 and left 1, so negative 3 over negative 1. And we get this point over here at negative 1, negative 5. And then we're just drawing the line through those points. And the equation of our line would be that y equals 3x minus 2. In this example, we're writing the equation in point-slope form of the line with a slope of negative 3/4 that contains the point negative 2, 5. Then we're going to graph it. Well, the point-slope form is y minus y1 equals m times x minus x1. We're given a slope and a point. So the point-slope form, we're just going to plug in those values. M is the slope, so that's negative 3/4. And x1 is negative 2, so that plugs in here. And y1 is 5, so that plugs in here. So we have y minus 5 equals negative 3/4 times x minus a negative 2. So x minus a negative 2 becomes x plus 2. And this is in point-slope form. If we were asked to put that into slope-intercept form, we could then distribute and move the 5 over and get y by itself. Now with point-slope form, it's really easy to graph that point, negative 2, 5. So negative 2, 5. And then use the slope to count rise over run. So negative 3, going down 3, right 4, down 3, right 4, and we could graph that line through those points. Now in this problem, we're going to write the equation of the line in slope-intercept form. So I'm given these points here, 0, 3, and negative 2, negative 1. Notice I'm not given the slope, so I'm going to have to find that first. So m is y2 minus y1 over x2 minus x1. Plugging those values in the formula, negative 1 is y2, 3 is y1, negative 2 is x2, and 0 is x1. So when we plug those in, we get negative 4 divided by negative 2, or positive 2. Now that we have the slope, we can plug in a slope and a point and plug those in. Notice, however, that they gave us the point 0, 3. When we have that point 0, comma, a value, that's actually our y-intercept. So they gave us our b value. So y equals 2x plus 3 is our equation. Write an equation of the line through each pair of points. So again, we're given negative 7, 4 and 9, negative 4. We need to find the slope first. So plugging into the slope formula, we get negative 4 minus 4 over 9 minus negative 7. So we get negative 8 over 16, which is a negative 1/2. Now we're going to use our slope and point to plug into point-slope form. I can plug in m as negative 1/2, and x1, y1 could be either point. Those are both points on that line, so I get to choose which point I plug in. So I'm going to plug in that very first point. Negative 7, 4 is x1, y1, and then m is negative 1/2. Now from here, I'm going to simplify and make that y minus 4 equals negative 1/2 times x plus 7. Now I'm wanting this in slope-intercept form. Right now this is in point-slope form. So I need to distribute the 1/2. So negative 1/2 times x is negative 1/2 x. Negative 1/2 times 7 is negative 7/2. Now I'm going to add 4 to both sides to eliminate this negative 4 and get y by itself. When I add 4 to each side, I have negative 7/2 plus 4, which is negative 7/2 plus 8/2, which gives us 1/2. And now we have our slope-intercept form. Y equals mx plus b. So from here we'd be able to see our y-intercept is 0, 1/2. In this one, we're going to write the equation of the line between negative 2, 6 and 5, 6. Notice that the y value is the same in both of those points. So when I find the slope, I should notice that my slope is actually going to be 0. When my slope is 0, I'm going to just try and plug that in and see what happens. So if I plug it into point-slope form, again, I can choose either point. I'm going to plug in 0 for my slope, and then plug in negative 2, 6. I could have chosen 5, 6, and I would have still ended up with the same equation. So now 0 times anything is just 0. So the only thing we have left on that right-hand side is just 0. Then add 6 to both sides and we get y equals 6. Notice that we no longer have that x term, which again we could have that as y equals 0x plus 6, again illustrating that y equals 6 has a slope of 0. So when we look at horizontal and vertical line equations, they're only going to have one variable in them because their slope is either going to be undefined or 0. In the case of the horizontal line, B is our y-intercept. So our horizontal line, we have a y-intercept of 0, -3. Notice on that line, all of the points have y values of -3. -1, -3 has a y value of -3. 4, -3 has a y value of -3. Everywhere on that line, y is equal to -3. And so we have that equation. For the x value, for the vertical line, we have x equals a value where a is the x-intercept of the line. So notice we have that x-intercept of -2, 0. Notice everywhere on that line, our x value is -2. X is -2, 3 at that point. -2, -1. Everywhere on that line, x is equal to -2. And our slope is undefined for vertical lines.